Hello, good evening all. Sorry for the delay because today I have some network problem and also power supply problem. So let us start with the first question. First question is, I am audible? Just please, anyone can write in the chat box whether I am audible or not.
Yes, sir, audible.
Okay, thank you. So let us start with the first question. The question one is the pitot tube is used for measuring the velocity of the flow, pressure of the flow, and flow rate, as well as on the fourth total energy. So please you can write your answer in the chat box for question number one. Or anyone, Kaushik, you want to ask something? You have raised the hand.
No, sir, just
Okay, it's okay. So okay, Abdul is telling option A, velocity of the flow. Please another participant also try to give the answer in the chat box as soon as possible. Then we'll move further on the next question. Okay. Okay, most of the student telling option A. Yes, option A is correct for this question. So pitot tube basically we use for measuring the your velocity. It is not working. Okay, this is. Now we'll move on the next question. Next question is, yes, very important question. Question is, a siphon used to empty a tank consists essentially of a pipe with its summit 2.5 meter above the water surface of the tank and its outlet at 3.5 meter below the summit. Neglecting the friction and other losses, the velocity in the siphon is. Which option is correct? Whether A 4.43, B option 5.42, C option 3.14 and D option 3.81. So please yes. So please try to solve the question number 2.
सर आपका शेयरिंग नहीं दिख रहा है.
Okay, now it is visible. Hello, now it is visible. Please just confirm.
ये या सर
Okay.
दिख रहा.
I think due to the some network problem, uh, we are facing the problem. Okay. Now I think network will be consistent. Okay, please. So try to solve the question number 2. So Manoj is telling the option number A is correct for question number 2. Okay. Okay, another participants also try to give your answer in the chat box. Okay. Bomik is telling option number A. Okay, 4.43. Okay, let us discuss. So here is question is, a siphon used to empty a tank consists essentially of a pipe with its summit 2.5 meter above the water surface. Let us suppose a tank is here, and in the tank the water surface is this. You can just imagine this is the water surface, right? And one siphon is connected like that. Now another, and its outlet is 3.5 meter below the summit. So let us suppose here is the outlet. This is the outlet, and summit is this. So this is 2.5 meter is given already in the question, and this is given 3.5. Now you can just think this value will be 1 meter. So you can apply the Bernoulli's equation here at this, let us suppose 1, and here at 2. So P1 by rho z plus V1 square by 2z plus Z1 is equal to P2 by rho z plus V2 square by 2z plus Z2. So here just I am assuming this is the datum. So Z1 will be 0, P1 and P2 will be P atmospheric, and velocity of in the tank will be 0, V1 will be 0. So only remaining part is this and this will be cancelled out, and your velocity is 0 and this is 0. So remaining part is V square V2 square by 2z equal plus Z2, this is not, plus Z2 equal to 0, and your Z2 is, if this is datum, when you will go downward, so it is minus 1. So V2 square 2z, this is minus 1, when we will go another side of equal to, it will be the plus 1. So now your V2 is equal to root under 2z 1 into 1. So your V2 value will be 2 into 9.81, it may be 4.43. Let us check meter per second. And let us, yes, option A will be correct for this. How you will proceed? just I discussed. So similar type of question you may think in your assignments or another competitive exams also. So now we'll move on the next question, question number 3. Let us see what is question number 3. So question number 3 is, which of the following is an example of free vertex flow? Example of free vertex flow: a whirlpool in a river, flow of liquid through a hole provided at the bottom of a container, flow of liquid around a circular bend in a pipe, all of the above. Which option will be correct? So please try to give your answer in the chat box for question number 3. Yes, please. So for question number 3, everyone please try to give your answer in the chat box. Okay, D. Manoj is telling option D will be correct. Okay. Another participants also try to give your answer. Okay, everyone telling is D. Yes, D will be the correct for this. Now we'll move on the next question. So everyone need to know about the what is free vertex. So if you know these things, then you can very easily relate all this your options. So please try to go with the lectures so you can very easily and very simple way you can got it what is the free vertex. By the way, we'll move on the question number 4. Yes, question number 4 is, a fluid of viscosity 15 poise and specific gravity 1.3 is flowing through a circular pipe of diameter 150 mm. The maximum shear stress at the pipe wall is 260 Newton per meter square. Find the pressure gradient in Newton per meter. So you need to calculate the pressure gradient in this question number 4. Option is given. So please everyone try to calculate. Read the question very carefully and try to give your answer. So please everyone try to calculate. This is very important questions. So I'll tell here 2-3 more concept in this question related to your pipe flow, about the maximum shear stress and about also maximum velocity variation in the pipe as well as your pressure gradient. So you have another 2 minutes for this question. Please try to calculate. Okay, for this question, your actually the question, if you will read the question, the finally you need to calculate the pressure gradient in this question number 4. So the value is given maximum shear stress as well as the specific gravity and the diameter of the pipe as well as your viscosity. So how you will calculate? So let us suppose this is a pipe. Just for your understanding, I am going to draw, and here is the diameter is given 150 mm. So your radius will be 0.15 by 2 meter. So how your pressure related to the your maximum shear stress or whatever the value is given in the question? So it is related with your tau max is equal to pressure gradient into, if this is x direction, into r by 2. This is, and your r value is, this is complete r, and let us suppose the varying with small r. So this is your pressure gradient. So you need to calculate the pressure gradient. So here you no need to, not need this value, the poise and the specific gravity, that is the viscosity and specific gravity not required. So 260 equal to, you need to calculate pressure gradient into r value is given 0.15 by 2, and another you need to multiply with the 2. So minus del pressure by del x is equal to 260 into 4 divided by 0.14. Let us calculate. So it may be, let me calculate. 260 into 4 divided by 0.15. So it is 6, 9, triple three. So you can go with your, here is the minus, so your del P by del X will be equal to minus 6, 9. So option D will be correct for this question. Now, the concept related to this question, another concept I want to tell you, because very important for exam point of view. Another exam also you can think. So if this is pipe, how velocity vary in the pipe? So your velocity variation like that. Remember please, parabolic. I am talking about here the flow condition is laminar. Okay, so the maximum velocity is here, U max. Similarly, your shear stress variation like that. If this is main line, if this is pipe, so your shear vary like that. At the wall, shear will be maximum like that. This is tau max. So in the question, tau max was given. So how it is related with your that is this is the your velocity. How this velocity and this is tau, how it is related? So your velocity is related with u max like that. Remember please, u max is into 1 minus small r. This is a small r and this is your capital R. Let us suppose you want to calculate velocity at this location, so you need to put the value of r at that. Let us suppose if this is 0.15, maybe 0.1 or another. Always remember please. So this is like that, and your tau is related with the tau max like that. Tau is equal to tau max r by, remember please always. So this is linear variation, linear, and this is your parabolic. So questions come from whether your tau variation in the pipe in case of laminar flow it is linear or parabolic, you can go through the linear. The velocity variation parabolic, how your pressure gradient related with the your tau max like that. Always remember please. Now we'll move on the next question. This is very important question through in the pipe flow. Now we'll move on the next question. Question number 5. Yes. So the dimension of kinetic energy correction factor is the dimension of kinetic energy correction factor. So please everyone try to calculate for question number 5. For question number 5, everyone try to give the answer. So again I am repeating, the previous question and the previous concept was very important for all exam point of view. So always remember please. So now the kinetic energy correction factor, okay, on the Bhomik is telling option B, okay, option B. Other student please also option C, okay, option C. Manoj is telling option C, Abdul also telling C. So what is correction factor? Kinetic energy correction factor. If you know, then you can give the very easily the answer of this question. And one question also I want to ask verbally. So the kinetic energy correction factor value in case of laminar or in case of turbulent flow. So please anyone can, or I want to ask in another way, whether the kinetic energy correction factor will be more in laminar case or turbulent case. So I am talking about more, in which case you can write laminar or turbulent in the chat box. Okay, in case of turbulent you are telling the kinetic energy correction factor will be more. I am talking here, let me write. So alpha value, let us, this is option A and this is option B. Alpha value for laminar, turbulent. Alpha value for laminar, turbulent. Which option will be correct? Whether A and B? First, everyone try to focus on question number 5, then this question. Then you focus on this question. So, which option will be correct for what I am asking? Okay, one student is telling option, okay, option A. Okay, you are telling the for turbulent, for laminar will be more. Manoj is telling for laminar will be more, and the Mani Kumari is telling option B, that is for turbulent will be more. Okay, Indrajit is telling also the for turbulent will be more. Okay, this was I think question in the previous gate in 2023 or maybe 2024. I didn't remember, but the question was, this question was from gate, whatever I am asking. Okay, let me discuss. So basically the kinetic energy correction factor, the dimension, this is actually dimensionless, so there is no dimension. So option C will be correct for this question. So your kinetic energy correction factor is nothing but, let me just draw the diagram. Your velocity variation in the pipe is, let us suppose go example with pipe flow. Let us suppose I want to draw two pipe here, another pipe this, and this is for laminar flow and this is for turbulent flow. So the velocity variation is parabolic in case of laminar, like that. But in case of your turbulent flow, velocity variation at the wall linear, then after logarithmic. Most of the part is logarithmic. You can say like that. Yes. Or let me draw here very clear. Like that. Straight little bit. Then logarithmic. Remember please. So this is case for turbulent, laminar, and this one for turbulent. So kinetic energy correction factor is basically your velocity or you can say here below also the velocity. But this is your velocity. So that's why the ratio of the velocity and velocity, but different velocity. So that's why the dimension is non-dimensionless. So but velocity is, I think here is your velocity at layer wise. That is, what is the velocity at that layer, at that layer? Okay, remember please. And another the velocity, average velocity. Another the average velocity. That is when you will average these things, what will be happen? This maximum part, that is average means what? Your velocity variation should be like that. The average velocity means here also value will be same, here also value will be same, everywhere your value will be same. This is the mean of averaging. When you will see in the turbulent flow, almost throughout the channel, at the wall, your velocity is very less. That is the your velocity varying, not like the here just you will draw the line here, you can just see like that. Otherwise throughout the channel your velocity almost, you just see, your velocity is almost same throughout the channel, but at the wall, near the wall, you can say near the wall your velocity is varying. Otherwise the throughout the channel is same. In case of laminar flow, your velocity is what? Your velocity is varying throughout the channel. You can just see here, here is more, here is more, here is more, here is more. So for kinetic energy, that is your kinetic what correction? The correction means you going to convert your velocity, that is velocity, layer velocity, into the average velocity. Whatever you will use your formula, area into discharge, that is your discharge is equal to area into velocity, you need to write the average velocity. Whatever in the you're going to write your velocity in the Bernoulli's equation, you need to write here the average velocity if you are not using the alpha value. Okay, so remember, so for averaging, so correction factor, just imagine here, the correction required for averaging this graph like that, this graph like that, and this graph like that, similar way, the correction is required in which, this is because it is varying from throughout the channel, it is varying only at the wall, so correction is required more in laminar case, correction is required more in laminar case than the turbulent case. So correction factor, that is your velocity, that is kinetic energy correction factor, because kinetic energy related to your velocity. So, because here why I am writing here only velocity, because kinetic energy means mass and mass will be cancel out everything, only velocity will be remain, that's why. So here for averaging this parabolic graph, you need more correction compared to this your that is a logarithmic type of profile graph. So that's why correction factor is more required in case of laminar than the turbulent. Always remember please the concept behind. Or everyone please go through the derivation of the kinetic energy correction factor, how you will calculate for laminar case as well as turbulent case. So this is the all about your kinetic energy correction factor. Now we'll move on the next question. So here you can see the kinetic energy, that is correction factor, is kinetic energy per second based on actual velocity, that is whatever the layer wise velocity, and kinetic energy per second based on the average velocity. Remember please. So here is the actual part, that is the actual, and here is the average velocity. Always remember. Now we'll move on the question number 6. The most essential features of turbulent flow is high velocity, velocity at point remain constant with time, large discharge, velocity and pressure at a point exhibit irregular fluctuation of high frequency. So please, this is very important question. So everyone try to give the answer. Hope everyone got it the previous question and the concept behind the kinetic energy correction factor. Also please everyone need to see moment correction factor also, you need to see whether for turbulent case more and for laminar case will be more. And also you need to remember the value, because sometimes for a special case in exam the actual value asked. So remember please, this is very very important. If you are preparing for some competitive exam, then it is very very important, you need to go through the all values of kinetic energy correction factor as well as the momentum correction factor. Okay, for this question you are telling, Manoj is telling option D will be correct. Other student please also try to participate, because I am looking the few student only giving the answer. Okay, D option. Two student is telling option D will be correct. Okay, okay, another student also. Okay, everyone telling, most of the student are telling the option D will be correct. Yes, definitely option D will be correct. Here I want to also talk about what is the meaning of your this fluctuation with high frequency. So actually in laminar case, if this is, actually you are measuring the velocity at a particular point, let us suppose you are measuring the velocity this at a particular point, let us suppose P, and in laminar case, if this is velocity and this side is decreasing, if this is time. So with time, at a particular time, velocity will be same. If the flow is steady, velocity will be same, velocity will be same, like that. Your velocity throughout the same. When you will connect the all the velocity measurements, you will get a straight line in case of laminar. But in case of turbulent, what you will get? In case of turbulent, if this is velocity, if this is time, with time, your velocity at a particular point, let us suppose this, another time when you will move with the, let us suppose 8 am, when you will move on 8.2 am, that is like that, your velocity will be fluctuate like that, not the constant like previous in laminar. Your velocity may be fluctuate like that. So remember please, so this part is known as your fluctuation part. And after that, for analyzing the turbulent, actually the turbulent flow, we need to, that is the approximate time average the velocity, we need to time average. So when you will average your velocity, your this velocity, that is this is, if this is u, this velocity will be divided in your time average as well as the fluctuation. So this is the fluctuation part, u dash. But in case of laminar, your u is equal to u. Here is the no fluctuation part, your fluctuation part will be 0. But in case of turbulent, your fluctuation will be there. So remember please, the meaning of this line option D is this. Now we'll move on the next question. Next question is question number 7. Question number 7, for fully developed laminar flow. Remember, fully developed laminar flow through a circular pipe with Reynolds number Re, the friction factor is proportional to Re, that is your Reynolds number, proportional to a square of Re, independent of Re, and inversely proportional to Re. For fully developed laminar flow. So what is the meaning of fully developed? I'll discuss here. But before my discussion, you please try to give your answer in the chat box. for question number 7. Very important question. Okay. Option D. Sanjay is telling option D for question number 7. Okay, let me discuss. Actually, the fully development length means here, fully developed laminar flow means, actually if this is pipe, at the entrance, if this is inlet, this is outlet, at the inlet, when your flow is entered in the pipe, what will happen? The velocity variation will be like that. Initially, your velocity will vary. If this is laminar flow we are talking about, your velocity will be like that. After that, like that. After that, after that, your velocity will be completely fully developed. So your velocity is varying when you will draw a line like that. So remember please, this length is known as your fully developed length, or you can LD, development length. So in case of laminar, after that your velocity will be always what? Parabolic variation in case of laminar flow. The diagram is not correct, so just remember. everywhere your at every section your velocity will be parabolic variation. Similarly, case of turbulent like that. So you please need to go through the textbooks. So what is the length of this in case of laminar LD? How it is related to your flow velocity and another parameters. And in case of turbulent also you need to know. Okay, come on this point, this question number 7. So how your friction factor, that is your RE related with the friction factor. So in case of laminar, in case of turbulent, you need to calculate the friction factor. That is you need to calculate the loss due to the pipe friction. So in case of laminar flow, it is related with the value is how you will calculate 64 by RE. And in case of this turbulent flow, you need to go through the Moody's diagram. Or one equation is given, very long equation, you need to remember. Sometimes in competitive examination can ask. So okay, here we are discussing about the laminar flow. So you need to calculate the friction factor using this formula. So here if you will concentrate in case of laminar, if your F is inversely proportional to RE, so your option D will be correct. But in meantime you need to go through here, you need to go through your the development length in case of laminar, in case of turbulent. Here you need to see two formulas and another formulas. You need to look the Moody's diagram. What is Moody diagram? So basically the main aim of the Moody diagram is to calculate the friction factor in the pipe in case of turbulent flow. In case of laminar flow, no need to go through the Moody diagram because here formula is given. But in turbulent flow, you need to go through, or the formula is given 1 by F something like that. So big formula. So the formula is given. So you need to also calculate the value using formula. Otherwise, you go through the diagram. What is diagram? So remember. Now we'll move on the next question. Question number 8 is, so when a steady two-dimensional jet of water impinges on a stationary inclined plate, and if the fluid friction is neglected, the resultant force on the plate is tangential to the surface, normal to the surface, in the direction of jet flow, normal to the direction of the jet. Option D. So here also I'll discuss some important concepts regarding related to this question. So before you need to give the answer for question number 8. So I want to take 5-minute break. So in between you can also take 5-minute break. Otherwise you need to solve the question of number 8. Okay. So Manoj is telling option D, G will be correct. Okay, B, someone telling B, normal to the surface, and Manoj is telling in the direction of jet flow. Okay. Okay, let us discuss. So question is two-dimensional jet of water. Let us suppose a water jet is like that. The water jet is like that. And pings on inclined plane. Let us suppose this is inclined with theta. With the horizontal, it is theta. And it is acting on that. What will happen? The some fluid part will go in this direction and some fluid part will go in this direction. This is a general understanding about this. Now, if the fluid fraction is neglected, you are neglecting the fluid fraction. That is the friction part you are going to neglect. Okay. That is the friction between your plate and this fluid. Like water is flowing in this direction like that. And also in this direction like that water is flowing. If this is your plate, let us suppose plate is like that. So the resultant of the force on the plate is whatever the resultant we are talking about. Always remember, please. We are not talking if this is x direction and if this is y direction. So we are talking about whatever the x component of the this x component, some, because this is on incline, so force, the force due to this jet, force will act in x direction, always also in y direction, Fy. And what is the resultant, that is the due to this, you need to convert these two force in a single force. So means you need to calculate the resultant. When you will calculate the resultant, the normal to the your plate, resultant will act. There is a simple mechanics, engineering mechanics, if you will remember. So normal to the surface option will be correct. So how you will calculate the x, that is the component of x and component of y, how you will calculate fx and fy if this is theta. So this is also very important. Sometimes, oh, I think some network problem. So how you will calculate? So let us discuss. So actually in this case, force is equal to, how you will calculate force due to whatever the mass is coming. Remember please, whatever the mass is coming, simple formula, if I tell you, force is equal to mass into acceleration. That is your change in velocity with respect to time. So that is your, that if I, the rate of mass flow means what, m dt, and change in velocity, that is m dot into dv. How you will calculate this normal part? So that is the complete force. So whatever the mass rate, what is the your mass rate? Mass rate is nothing but m, that is the rho a, that is the area of your, and velocity, whatever the velocity of this, and area of your jet. Okay, and what is the change in velocity? So initial velocity your is, that is u, that is, if this is v, initial velocity is v, and final velocity there no movement because this is fixed, so 0. So your normal value, that is the normal force, whatever the this normal component Fn will be rho a v square. And now this is very simple. If this is inclined plane and your normal one force is acting Fn, and if this is theta or this is x value in the direction, if this is theta, similarly this value will be theta, this value your will be theta, f x, in this direction fy. If this is theta, from here if you draw a line, this will be theta, and this is your 90-degree hole between the fx and fy is 90-degree. That is the rectangular component concept here. That is the fx and fy, that is a rectangular component concept from your engineering mechanics, that is 90-degree. So this will be your, this value 90 minus theta. So your fx will be fn cos 90 minus theta. Similarly your fy will be fn sine, not this, fn sine 90 minus theta. So what is fn? Now you can write very easily, your fx value is, fn value is rho a v square into cos 90 minus theta, and your fy is rho a v square sine 90 minus theta. So always remember please. So sometimes how you will calculate this m by dt, m by dt, that is unit is kg per second. So whether this value is giving kg per second or not, let us go with the kg per meter cube, go with the your unit, and this is meter square in meter per second. So this meter cube and meter cube cancel out, so kg per second. So whatever we have writing at the place of m by dt is rho av, this is correct. So the expression is correct. So like that you can check also. So we'll move on the next question. So this is the whole concept behind your inclined fixed plane. So you can go one by one for your vertical as well as vertical fixed plane and flex, and also movable plate also you can go through. So this is up to you whether you want to go through or not. But by the way, the next question is, the shear stress developed in a pipeline containing water is 6 Newton per meter square. What is the shear velocity in the circular pipe? The value of rho is given like that, 1000 kg per meter cube, and the option is 0.0516, 0.0632, option B, option C 0.0774, and option D 0.0732 meter per second. So everyone please try to calculate this question. Hope everyone got it the previous question. So uh, now you need to solve the question number 9. Everyone please try. Everyone please try for question number 9. So here a shear velocity you need to calculate. So first you need to know what is the formula of shear velocity. So if you know, then you can very easily calculate. How your shear velocity is related with your shear stress as well as density, because you have only two known values here and you need to calculate one unknown. So if you have some idea about the relation between two known value and another unknown value, so very easily you can calculate. Okay, so now let us discuss. So basically your shear stress, shear velocity here you need to calculate. Let us suppose represent it with the U star. So it is related with your shear stress developed divided by rho, root under. So this is a simple formula and you need to put the value root under 6 by 1000 U star. So you can very easily get, let me just, yes, 0 point or 774. Option C will be correct for question number 9. Remember please, this is very important. Now we'll move on the question number 10. Question number 10 is the equation of motion of the laminar flow. The equation of motion for the laminar flow of a real fluid is known as. For laminar flow we are talking here. Euler equation, Bernoulli equation, Navier-Stokes equation, Pauli equation. So which option will be correct for question number 10? The equation of motion for laminar flow. Similarly, sometimes the question will be on the equation of motion for turbulent flow. So here you need to give the answer about the laminar flow, equation of motion of laminar flow. Okay, for previous question, Manoj is telling option C. Yes, option C correct. But for this question, question number 10, please try to give your answer. Everyone, please try to give the answer. Okay. So basically the equation of motion for laminar flow, let me just show you the answer. For real fluid, we are talking about here the for real fluid. So the equation of motion for laminar flow of a real fluid is known as Navier-Stokes equation. Remember please option number C. Okay, here is question number 11 is the shear stress in turbulent flow is due to. The shear stress in turbulent flow is due to the viscous property of fluid, the fluid density, the fluctuation in the velocity in the direction of flow, and the fluctuation in the velocity in the direction of flow as well as transfers to it. Option D. So please for question number 11, everyone try to give the answer for question number 11. So Mani Kumari is telling option D correct. Okay. Okay. Manoj is also telling. Sanjay is also telling option D. Other student, please also try to give your answer. Okay. Everyone telling option D is correct. Okay. Now, yes, option D will be correct because in case of your turbulent flow, your shear stress is like U dash and V dash. Whatever I was talking previously, the dash value, that is your in turbulent flow, your velocity is divided in two parts, that is the U dash, U is average and U dash. Similarly, in lateral direction also your velocity like that, that is the V average and V dash. In vertical direction also your velocity is like that, W average plus W dash, like that. Remember please. So it is related like that. Now we'll move on the next question. Next question is the major loss of energy in long pipe is due to sudden contraction, friction, gradual contraction or enlargement, sudden enlargement. The major loss of energy in long pipe is due to. Very important question for question number D. No, question number 12. Okay, B option. Other student, please also. Okay, B option B. Everyone telling I think B. So we'll move on the next question. Okay, so now I want to share another assignment. Okay, so hope it is visible to all of you. Please, anyone can write yes in the chat box so I can.
Yes.
Okay, okay, thank you. So the question number one, this is from your whether I can write or not. So this is your hydraulic engineering NPTEL. Here is written 2023. Previous one was 2024, but this is from 2023. The question is the Bernoulli equation is applicable between any 2 points. Option A, in any rotational flow of an incompressible fluid. Option B, in any type of irrotational flow of a fluid. In steady rotational flow of an incompressible fluid. Option D, in steady irrotational flow of an incompressible fluid. So here four option. So this is also very important question. But such type of question, I think nowadays in competitive exams, not expect. But the associated question from Bernoulli's equation you can expect. So because nowadays competition is very high, lots of contents are available online and also offline for your study and all. So that's why competition is very high. So please, if anyone preparing for competitive exams, so please go through each topic for each subject, and you need to go very deeply. So okay, by the way, for the you need to write the answer for this question number one. Bernoulli equation is applicable between any 2 points in which, that is here actually related. This question is from the assumptions, the Bernoulli equation assumptions. Okay, option D, in steady irrotational of an incompressible fluid. Okay, option D, two student telling option D. Other student, please also try to give your answer. Okay, so I think everyone telling is D. So yes, D option will be correct. So we'll move on the, here is you can see the assumptions. The fluid is ideal, that is viscosity will be 0. The steady flow, incompressible, irrotational. This is the assumption from your Bernoulli's equation. Now this question, everyone please try to calculate. In previous, this is related to your previous question was the siphon, but here you need to, everyone need to calculate and write your answer in the chat box. Please, everyone. For question number 2, a siphon used to empty a tank consists essentially a pipe essentially of a pipe with its summit 0.5 meter above the water surface of the tank and its outlet at 2 meter below the summit, neglecting the friction and other losses. The velocity in the siphon is option A 4.4 meter, option B 5.4 meter, option C 3.1 meter, and option D 3.8 meter. Okay, Manoj is telling option D for this question. You are telling for this question and another question, previous one. Manoj, you can write your again answer if you are telling about this question number 2. Otherwise, if your answer about the previous one, that is for question number 1, it is okay. So everyone please try to calculate. Important question. Okay, for question number 2, uh, your option is D. Sanjay is telling option B. Okay, Manoj is telling option mm, D, that is 3.8, and Sanjay is telling B 5.4. Okay. Other student, please also. Everyone, please try to calculate using your copy and pen, and also you can use calculator. You always try to use calculator, that is the gate calculator or online calculator, whatever you will get in your exam, final exam. Always try to calculate using that calculator only, because at the end of your final exam you need to have only that calculator, online calculator, not this your calculator, that is a Casio company calculator. Option B. Okay, 3 student telling option B. Let me just, because here I'll not discuss about more, I'll just write here the your formula, that is V square is equal to 2gh. That is the h is equal to nothing but 2 into 10, and h is equal to the difference between this, that is 1.5, 20 and 15, so 30. So when you will take the 5 point something, that is option B should be correct. Let me just go through. Yes, option B is correct. So everyone got it. If you're not able to understand why I have written here root 2gs, so please go through the video whatever I will upload. It may be after 2 hours you may access the video. So now we'll move on the next question, because previously I have solved this question very conceptually with applying the Bernoulli's equation and all. So for time mean we'll move with the, because we have lots of questions. So the next question is, in a flow of a real fluid with no addition of energy. In a flow of real fluid with no addition of energy, option A, the energy line will be horizontal or sloping upward in the direction of flow. The energy line can never be horizontal or sloping upward in the direction of flow. The energy line will be horizontal or sloping downward in the direction of flow. Option D, the energy line can never be horizontal or sloping downward in the direction of flow. Question number 3 is a very conceptual question. Here is a very conceptual question. So because we are talking about real fluid, so and with no addition of energy, we are not giving the energy. So just try to think. So for question number 3, everyone think and write your answer in the chat box. Option B telling everyone okay. The energy line can never be horizontal or sloping upward in the direction of flow. Okay. Okay. So let me discuss, or let me just show you the answer. So here we are talking about if a flow in a flow of real fluid with no additional energy, let us suppose if flow is moving in this direction like that, that is, so the energy line will be where is the energy line will be horizontal or sloping, maybe horizontal or sloping upward in the direction of flow, like that, upward. It is possible? Not possible, because due to the loss, because when your fluid will move, the loss of energy, it may be downward. The energy of line horizontal or sloping upward in the direction of flow can never be horizontal or sloping. Can never be horizontal or sloping. Oh, this is also wrong. It may be sloping, or it may be horizontal upward in the direction of flow. Okay, the, let me just read very carefully. The energy line can never be horizontal or sloping upward in the direction of flow. Okay, if the losses is there, then this option may be correct, because the energy line can never be horizontal if the loss is there, because this is a real fluid, definitely loss will be there. Okay, let us read the third option. The energy line will be horizontal or sloping downward in the direction of flow. The energy line can never be horizontal or sloping downward in the direction of flow. That is this is your A and B, and the option your C and D is what? The energy line will be horizontal or sloping downward in the direction of flow, like that. Maybe horizontal or maybe sloping downward, like that. The another can never be horizontal or sloping downward, like that. So here your answer should be like that. If this is a horizontal channel, if this is a sloping channel, your energy line will be like that, sloping in downward, will be like that, because due to the losses, it may be. Let us see the what is the answer. Yes, option C will be correct. Remember, please, option C will be correct, because the losses will be there. Due to the losses, your line will be downward direction. That is, here is high energy, here is low. As you will come in the downward direction, energy will be low and low. So that's why your option C will be correct. Remember, please. Now we'll move in the next question. Next question is okay. So a fluid of viscosity 12 poise and specific gravity is 1.2 in the flowing through a circular pipe of diameter 100 mm. The maximum shear stress at the pipe wall is 240 Newton per meter square. Find the pressure gradient in Newton per meter square per meter. Everyone please try to calculate, because I have discussed the concepts as well as the formulas. So everyone please try to calculate for question number 4. Which option will be correct? So hope everyone got it the previous question. So So for question number 4, everyone please try to calculate, because I have just discussed just few minutes or few, you can say the 1 hour back, the concept, the relation between your maximum shear stress and the pressure gradient. Okay, Manoj is telling option D. Okay, other student please also try to calculate. Okay, let me just write the formula. The your maximum shear stress is related with your pressure gradient, like that. R value is here 100 by 2, that is 50 mm. You can say 0.05 meter. So here you need to put 240 equal to, you need to calculate these things into R value 0.05 divided by 2. So it is what, like 20 and 5 fours are, and here 0, this value is, that is your minus dp by dx. So option D will be correct. Very easy question. So we'll move on the next question. Next question is question number 5. The dimension of kinetic energy correction factor. We have already discussed a lot about this question. Now we'll move on the next question. Yeah, this is very important question. Next question is, two parallel plate kept 200 mm apart have laminar flow of oil between them with a maximum velocity 2 meter per second. Calculate the discharge per meter width. Discharge per meter width. Assume viscosity of the oil is 24.5 poise. So option A 0.01 meter cube per second, and discharge per meter width. Okay, and here you need to write meter, discharge per meter width. So 0.05 meter cube per second per meter and 0.1 meter cube per second per meter, or per meter width, and 0.266 meter cube per second per meter width. So here width everywhere. So everyone please try to calculate. Very important question. Question number 6. Important question, please. Everyone, please try to think. Okay, let me discuss. So here is two parallel plate is, remember, like that. Two parallel plate, you can think. The distance between these two parallel plate is 200 mm. That is 0.2 meter. Okay. And viscosity is given already you 24.5. Calculate the discharge per meter weight. So discharge formula is area into velocity. That is average velocity, I have already told you. But in the question is given maximum velocity 2 meter per second. How it is related? That is your, in case of parallel plate, your maximum velocity is 1.5 times of your average velocity. So from here you can calculate your average velocity is u max, that is 2 by 1.5 meter per second. This is average velocity. So area is what? And here area is, you know already, the area of cross section. Area of cross section means width. Width is given your 1 meter per meter, here is talking, so 1 meter is given, and your, that is your height, that is your depth is given 0.2 meter. So, or you can say, right, q, small q, that is your capital Q by b. So your b is 1, that is a width is 1, this value, width value, If the width of the plate is 1, like that, this two plate is like that. Just you can imagine. The width is 1 meter. Remember, and in between the oil is filled with completely filled oil. So small q, if I write the small q is, that is your depth 0.2 meter into your velocity, average velocity 1.5. So you can write here 0.4 divided by 1.5, cancel out. So it may be your, if you will, maybe your option D will be correct, because yes, option D will be correct. After calculation you will get 0.266 meter cube per second per meter. So this is the answer. Now we'll move on the next question. Next question is, yes, for viscous flow the friction factor is given by, for viscous laminar flow, here remember please some missing part, viscous laminar flow the friction factor is given by. For question number 7, please, I need answer from all participants. Okay, everyone please give your answer in the chat box. Just write your answer. Okay, Sanjay is telling D. Other student please also. Okay, most of the student telling option D. Yes, D option will be correct, 64 by RE, because I have discussed about this concept lot, so I will not discuss here much. We'll move on the next question. Question number 8. Question number 8 we have discussed already. Question number 9 is, yes. Here everyone please try to calculate. The shear stress developed in pipe and containing water is 4 Newton per meter square. What is the shear velocity in the circular pipe? This the formula and concept I have talked already. So please everyone try to calculate and everyone try to give the answer for question number 9. Okay, Manoj is telling option B. Everyone please try to give your answer. I'll wait 2-3 minutes. So one student Manoj is telling option B. Okay. Other student please also give your answer. Shear velocity. The question is shear velocity. Okay. Sanjay is also telling B option. Okay. B option. Three student is telling option B. Okay, I want to let us discuss about this question. So basically here the shear stress develop in the pipeline is given already. That is 4 Newton per meter square, and the density also given 1000 kg per meter cube. You need to calculate shear velocity. How it is related with these two known value. So shear velocity let us use with the U star, sometimes UF, small f. So it is related like that, tau divided by rho. You need to put the value here. That is 4 divided by 1000. And now let me calculate. 4 divided by 1000 is 4 divided by 1000 and root under. That is your 0.0632. Very simple. So like that you will calculate. So hope everyone got it. Question number 9. So now we'll move on the next question. Question number 10. Equation of motion for laminar flow of a real fluid is known as. So this question we have already solved. So but here I want to discuss about what is the Euler equation, Bernoulli's equation. What is the difference between actually the Euler and Bernoulli's and Navier-Stokes equation? So actually in Euler equation, the basic difference is here is the viscous force, that is your force is equal to mass into acceleration. Everyone know, or you can say mass flow rate into change in velocity. So for calculating the force in case of real fluid, so you need to consider the all forces. What forces? Force due to body force, that is the weight of your fluid, Another important force is pressure force. Another important force is viscous force. Force due to viscosity of the your fluid. In Euler and Bernoulli's equation, in the mass and velocity is here, but in force part only two force is considered. Force due to body as well as force due to pressure. But in case of Navier-Stokes equation, all three forces, force due to body plus force due to pressure plus force due to your viscous. That is all three important forces considered in case of Navier-Stokes equation. That's why it is very important equation for in case of fluid flow, or you can say for your equation of motion for laminar flow or real fluid flow, you can say. And now we'll move on the next question number 11. So this is also we have solved. Shear stress in the turbulent flow is, this is the same question was in the previous assignments. The shear stress in case of turbulent flow is due to your transverse as well as your in the direction of flow, u dash and v dash, like the average. So this is, now the question number 12 is, yes, question number 12 here we have already discussed about that also. The losses through fluid flowing in the pipe due to friction. Actually this question was, previously the question was the major losses due to friction, but here is the due to the friction what type of loss, whether it is minor or major, both heavy. So the actually losses in the pipe is two, minor, all you know already, minor as well as major. So major your due to the friction, and minor lots of, that is the bend, and you can say the sudden opening, or you can say sudden closing also, and another also you can think about that. The minor other losses, the major losses only due to the friction, or you can say the you can consider the other losses in minor losses. So that's all. Here also written which the head loss through the fluid flowing pipe due to the friction is major loss, and the minor losses are those which are caused of account of total disturbance produced by such the fittings, walls, bend, etc. Sudden contraction or enlargement. So like that. So we'll, I'll close here for today. We'll meet on next Friday. So thank you all. Now everyone can leave the, okay, thank you. Everyone can leave please. Okay, thank you. Yes. Please everyone leave, then I'll close the class. Everyone please leave as soon as possible. Okay, thank you. Thank you, Iqbal. Okay, thank you all. Now I'm going to close.